Welcome back, dear students. In last lecture, we had seen the different radii of the atoms and molecules, including atomic radius, ionic radius, then covalent radius, and van der Waals radius. What is meant by atomic radius? It is the distance between the nuclear to outermost shell of an atom. Then what is ionic radius? It is the distance between nuclear to outermost shell of an ion. It could be cation or anion. And then covalent radius is the distance, half of the distance between the two nuclei of a covalently bonded molecule. And then lastly, the van der Waals radius is nothing but the half of the distance between the two nuclei of the two atoms which are in close proximity and from different atoms. So all these were the definitions of atomic radius. Then we had seen the variation of the atomic radius. Sorry, we didn't see the variation. Then we had seen the effect of charges on the various radii. As you know, the anionic radius is higher as compared to that of atomic radii, and which is higher as compared to that of cationic radii. So, as positive charge on a cation increases, the size of the cation decreases. As negative charge on an anion increases, the size of the anion increases. The size of the anion increases. As cationic charge increases, the size decreases. As anionic charge increases, the size increases. So remind this in your or make note this in your notebook. So here is the example of oxygen in case of anionic charges. Neutral oxygen atom has much more or a smaller atomic size. Then the O minus anion has higher size as compared to that of oxygen. Then O negative has further higher size. So as anionic charge increases or negative charge increases on an atom, then the size of the anion increases. Now we will see the variation of atomic radii along the period and in the groups. So see, when we go from left to right in a period, at that time the atomic radii decreases from left to right. Why this occurs? This is because as we move from left to right, the atomic number increases and also the nuclear charge increases. Also, the nuclear charge increases and the electrons are more tightly bound to the nucleus. The electrons are more tightly bound to the nucleus, so that the atomic size of the elements from left to right in a period decreases. Meanwhile, when we go from top to bottom in a group, at that time the atomic size increases. This is because with increase in atomic number, the nuclear charge also increases. But when we go from one period to another period, when we go from one period to another period in a group, at that time what will happen is that a new extra shell is being successively added to the atom, and this expands the shells of the atom, so that this expansion is higher as compared to that of the nuclear charge, and hence the size of the atom increases. Also, the electrons are loosely bound to the nucleus and the size of the atom increases. Then after completion of the atomic radius chapter, we will see the next, that is the ionization enthalpy. That is the ionization enthalpy. This is the second property of the element or periodic property of the elements. Now see, what is meant by ionization enthalpy? The energy required to remove the most loosely bound electron from the outermost orbit of 1 mole of isolated gaseous atoms of an element is called ionization potential or ionization enthalpy or ionization energy. You can say anything of all these three. It is the amount of energy that is required to remove an electron from 1 mole of an atom in its gaseous state. In its gaseous state is known as ionization potential. Now see, as I told before this in the ionic radii, that when an atom is subjected to remove an electron from that atom, at that time that is converted into a cation. Okay. Now in this conversion of cation, there is need to give some energy to the atom in its gaseous state so that electron can be removed. Electron can be removed. So see, the energy required to remove that electron is ionization enthalpy. Ionization enthalpy. So remind that ionization enthalpy is always positive. So the next is, an electron cannot be removed directly from an atom in the solid state. For this purpose, we have to convert the atom into its from solid state to its gaseous state, so that the energy is required, and the energy required to convert an atom from solid state to gaseous state is called sublimation energy. That energy is called sublimation energy. So that to remove the electron from that atom in its gaseous state, one electron from that atom is called first ionization energy. The first electron can be removed by providing some energy, and that energy is known as first ionization enthalpy or first ionization potential. Okay. If you want to remove the second electron also from the atom, at that time you have to add some energy to the atom, and that energy is known as second ionization enthalpy or second ionization potential. Now similarly, third ionization energy, fourth ionization energy can be seen in the trend. Then when we go from first to second, second to third, at that time the ionization energy increases. It means the values of first ionization energies are smaller as compared to that of second ionization energy, and then which are further less as compared to that of third ionization energy. It means as we go deeper to remove an electron, the energy required is higher. The energy required is higher. Okay. So you must keep in mind that the energy required to an electron from an atom in its gaseous state is known as ionization enthalpy. Now the next is the factors affecting ionization potential or ionization enthalpy. The factors affecting ionization potential. So the first factor is atomic size. The first factor is atomic size. As you know, everything that happens in this universe that has a cause, or that is called factor. So when we go in the periodic table, at that time there is variation of ionization enthalpy in the period, and this variation is due to some factors, and these factors are atomic size, effective nuclear charge, shielding effect, stability of half-filled and full-filled orbitals, and penetration power. All these are the factors that are responsible for the variation of ionization potential in the periodic table. Okay, the first is atomic size. Now see, in this case, the atomic size is inversely proportional to the ionization enthalpy. The atomic size is inversely proportional to the ionization enthalpy. As the atomic size increases, the ionization potential or ionization enthalpy decreases. Okay, because as size increases, the electrons are loosely bound to the nucleus, because this is because the distance between the electrons and the nucleus increases, and that causes less attraction force between the electrons and nucleus, and the electrons can be easily removed from the atom, so that the ionization potential or ionization enthalpy is inversely proportional to the atomic size. The next is effective nuclear charge. This is also very important point, because as the charge increases, that is nuclear charge increases, the ionization potential also increases. Therefore, the relation in between the nuclear charge and the ionization potential is directly proportional. The relation in between the ionization enthalpy and effective nuclear charge. So atomic size decreases with increasing the effective nuclear charge, because higher the effective nuclear charge, stronger will be the attraction of the nucleus towards the electron of the outermost orbit, and higher will be the ionization potential. It means higher is the nuclear charge, the atomic size get contracted and the electrons are tightly bound to the nucleus, so that these tightly bound electrons can be removed by applying higher ionization potential or higher energy, so that the ionization potential is higher if the effective nuclear charge is higher. There is direct correlation in between the ionization enthalpy and effective nuclear charge. The next is shielding effect. In this, the electrons of internal orbits repel the electrons of the outermost orbit, due to which the attraction of the nucleus towards the electron of the outermost orbit decreases, and thus atomic size increases and the value of ionization potential decreases. There is relation in between the shielding effect and the ionization potential is inverse. Ionization potential is inversely proportional to the shielding effect, because if there is a greater shielding effect at that time, the electrons are loosely bound to the nucleus, so that the loosely bound electrons can be easily removed from the atom, and hence this decreases the ionization potential of the atom. Now, as if you don't know the shielding effect, then I will tell what is happening in this shielding effect is that the electrons in an atom are placed in the shells one by one. Some of them are very close to the nucleus and some of them are away from the nucleus. The closer electrons make obstacles from the nuclear charge or from the outer electrons, so that the nuclear charge cannot be experienced by the outer electrons, and the electrons are loosely bound to the nucleus, and electrons experience less nuclear charge and the ionization potential is lesser or further lower. This is similar to that of if you go outside during the rain, and if you don't have umbrella at that time, the rain will be faced by you directly, but if you have umbrella at that time, you will experience less rain, or you can suffer less due to rain with umbrella. So that this shielding effect is nothing but it is similar to that of umbrella. Okay, the next is stability of half-filled and full-filled orbitals. The stability of half-filled and full-filled orbitals. The atoms whose orbitals are half-filled or full-filled have greater stability than the others. It means if an atom is half-filled or full-filled, at that time it is very hard to remove the electrons from that atom, and the ionization potential increases, so that the ionization energy of zero group elements is highest in a period, or in the periodic table. The next is penetration power. As you know, s orbital is closer to the nucleus, so that it has highest penetration power. Higher is the penetration power of an orbital, higher is the ionization potential. In any atom, the s orbital is near to the nucleus in comparison to the p, d and f orbitals. Therefore, the greater energy is required to remove out electron from s orbital than from pure p, d and f orbitals. Thus, the decreasing order of ionization potential of s, p, d, f orbitals is s has highest penetration power or highest ionization potential, then p has highest, then d, and lastly f orbital has the highest ionization potential. So in this lecture we have seen the variation of the atomic radius in groups and in period. Then we have seen what is meant by ionization potential and the factors affecting to the ionization potential. In next lecture we will continue. Up to that, thank you, best luck.